Previously, we have worked with factored forms of polynomials, but what do we do when something is not easily factored? With quadratics, we could use the quadratic formula, but what about when we get to higher degree polynomials? Well, we're going to begin today by looking back at a process you're very familiar with of just basic long division. For example, if I take 13 divided by 3, 3 goes into 13 4 times. And then I multiply 4 times 3, which gives me 12. I subtract those and I end up with 4 and a remainder of 1. This is called our divisor. This is called our quotient. And here we have our dividend. And then last but not least, this is the remainder. If the remainder is 0, then we know that the values are factors of each other. So for example, 13, or let's do 12 divided by 3 is 4. The remainder is 0, so 3 and 4 are factors of 12. Well, the same thing can be done with polynomials, and this will help us when we're looking to simplify these polynomials of higher degree. So for example, if we have a polynomial p of x, we can divide it by some divisor that is also a polynomial. And the answer we get is some other polynomial, q of x, or the quotient. And it can leave us with a remainder, which can also be the form of a polynomial. This polynomial is going to be of lower degree than the divisor. And if that remainder polynomial happens to be 0, then the remainder is 0. And so likewise, we then have the factors of p of x are going to be q of x and d of x. So let's look at an example of this division. If we divide some polynomial by a divisor that happens to be first degree, so notice this is something like x minus 4. Then when we divide this, we know that this has to have a lower degree. And if the degree of the divisor is 1, then the degree of the remainder here must be degree 0. And since that has degree 0, this is going to be a constant. So if we divide by a polynomial of degree 1, then that remainder is going to be a constant. If that constant happens to be 0, then we know that p of x is equal to q of x times x minus c plus 0. If that's 0, then we know that this is a factor, and this is also a factor. So p of c, if we plug in our c value here, notice this comes out to be 0. So therefore, p of c equals 0, and this tells us that c is a solution to p of x. This leads us into what we call the theorem of zeros and linear factors. If we have some number c that is a 0 or a solution of a polynomial, then we know that x minus c is a factor, and this means that p of c is 0. We can also then move into the remainder theorem, which tells us that if we divide some polynomial by a polynomial x minus c, the remainder is p of c itself, and it can be rewritten this way. Remember then that if p of c happens to be 0, then c is a solution of p of x.